Did you see the Soprano series and do you know what the Tony Soprano has from his dad and his mom? What is the inheritance in the object-oriented programming and what is the implementation and composition? All of this in this video. Enjoy! Implementation, inheritance and the composition in the object-oriented programming. Inheritance in the biological means is the passing of the traits from parents to their offspring. Putting aside the generics and the simplifying things, if granddad has blue eyes, dad has blue eyes, I will have the blue eyes. But let's introduce the actors here today. Me, my dad, Carl, and my granddad, Ted. Why do we need actors? It will be easier to understand the concepts once we will get to the code. There's one thing more, before we go further, implementation. Firstly, let's define interface. In our family case, interface will be human, because we are human. We act like a human, we talk, we walk, we can communicate, we are intelligent. All this makes us human. In this case, all of us, me, my dad, my grandpa, we implement interface with all of the, let's say, methods from the human interface. So, how it will look like in the code? Let's define the human interface first. What is the unique ability of human? We can talk. Let's define it as the method signature here. Now it's time for an implementation of this interface. Do you remember my granddad? Let's add a class representation here with the implementation of the talk method. Focus on the implements keyword here. And now let's define class representation of my dad. Again, we implementing talk method with the different message. Additionally, take a look on the extend keyword. This is extending inheritance. Carl inherited after Ted. Time for me. Patrick class extending Carl class with changed talk method output. If you need, pause the video and study the code. Alright, let's run it. Create instance of each class and invoke the talk method. As you can see, everyone introduced themselves. So far, it doesn't look impressive, right? As I said, we implement the talk method and extend the classes after their parents. But we didn't inherit much. Let's add something. Putting aside the biological rules, let's say that if my granddad had the blue eyes, my dad has the blue eyes, that I will have blue eyes for sure. So, putting that into the code, we define a color method which will return one of the enum values. Plus, let's implement this method in Ted class. Now, because of the inheritance, all of the children classes, Carl and Patrick, will have blue eyes. Let's add the method invocation calls and run it. As we expect, Ted, Carl and Patrick have the blue eyes. What if we'll add the biological mix and say that my mom has some other eyes color? So I will have the different than the Ted and Carl. We can override the method in the children class, so Patrick will have brown eyes. We know what is the inheritance and the implementation based on the family of mine. Let's define more business-wise scenario. How about a car rental? In this case, we would declare the vehicle interface which will be implemented by a car. But maybe car rental grows a little bit and offers the trucks. It's a good idea to extend the car. Now, car rental expands to the new fields and offers the helicopters. It sounds logical to extract the aircraft as their parent. And again, car rental expands, and now they need to be able to rent ships and sailboats, for instance. Because of the different types of the engines in those two, let's introduce a watercraft parent. Time to dive into the code. First, let's define the vehicle interface, which will be able to move. The movement will depend on the vehicle type, so we don't need to decide now if it will be driving, flying or sailing. Then start to implement the parent classes, aircraft, car and the watercraft. Time for an actor classes. We just created helicopter that extends aircraft and has its own way to move. The same for truck, extends car, and the ship which is extending the watercraft. If we would have the canoe, it would extend the watercraft as well, but it's paddling for sure. Is there something wrong with such an implementation? No, it can be just done differently. In the, let's say, normal projects, we are using it often. We have sealed classes which are being used just as the ones I just showed. But I have one thing more for you, the composition. Composition is the alternative for extending. It is the way of defining classes out of the smaller blocks. Library contains books, bus contains passengers, and so on. In our case, we will still have the actor classes, but now they implementing the vehicle interface and consist of the fields, depends on the specification of each class. Each one will have different values for power source and move strategy field. To the code. Let's define the vehicle interface and abstract class abstract vehicle. We will use it for keeping the fields and executing the logic for moving. Once we have the power source and move strategy field, we need to define the types for it. For power source, let's use enum class, but for move strategy, interface. Now we need to perform the moving. On the move strategy field, we call move method, plus we log out the power source type. We have all of the groundwork for the actor classes. Let's add them. Canoe, ship, truck, and helicopter. Each one has different values for existing fields. Canoe is being powered by the paddles and it's sailing. Ship is sailing too, but thanks for the engine. Truck powered by engine driving, and helicopter flying because of the engine. You know what will happen next. That's right, let's run it. Are the results correct? Canoe is paddling, ship is sailing, truck is driving, helicopter is flying. All of them powered by the different sources. Is it better solution? No. As I said, we use both of the concept on the daily basis, depends on the need. Even in this particular case, we use all of the terms we discussed today. Implementation, inheritance, and decomposition. As you see, using one is not the reason to not to use the other. One tricky thing I put in this example is the type of the power source and the move strategy. For the first, I use the enum class, for the other, the interface. Why? Let's imagine that you want to add the another type of the power source, wind for the sailboat. You need to refactor existing enum classes. In case of adding the new move strategy, it could be using the railroads for the train. There is no need to modify existing code. We are just adding the new one. But I didn't say that it's bad to use the enum classes. It is a part of the language syntax and you should use it. Just want you to know that there are many ways to solve the same problem. That's it. We just learned what is the implementation, how inheritance works, and how to compose classes out of these small pieces. What do you think about learning stuff in such a graphical way? Let me know in the comments and don't forget to hit the subscribe button because the new episode is on the way. Cheers!